So now let's start working on some of these mixed mole problems. So the first problem says, if we have 15 grams of N2O4, how many moles of oxygen are produced? First thing we ask ourselves is how many times is mole mentioned in the problem? Well, it's mentioned one time. So we're going to need two conversions. So now we're going to look at the reaction. We're going to check to see if it's balanced, and it is. So I can use that checklist. So good. Now I'm going to start setting up my game plan. So the number, unit, and substance given in the problem is 15 grams N2O4. And that's a unit other than moles. So that is going to go in the valley. So I'm going to have 15 grams, and that's going to go here. Now I want to get to moles. That's going to be our first step. So the first thing I'm going to want to do is figure out molar mass of N2O4. So that's going to be 2 times 14.01 plus 4 times 16, and I'm going to get a molar mass of 92.02 grams per mole. Now, once I'm at moles of N2O4, the problem is saying how many moles of oxygen gas I'm going to need. So what I do, in order to go across the bridge, I need the coefficients. So I have a 2-to-1 ratio. So now I know the two steps that I'm going to need to do. I'm going to need to first convert to moles, then go mole to mole using the coefficients. So now I am ready to set up my train tracks. So I have 15 grams, and make sure we put our substance, put it over 1. Grams of N2O4 come to the bottom. Moles of N2O4 come to the top. Now, when we're going from mole to some other unit, 1 goes next to mole. The number next to gram is going to be 92.02. Cancel my units. If I stop here, I'm at moles of N2O4. So what I've now just done is I've done given to moles. Next, bring mole N2O4 down. I want to get to moles oxygen. So whenever I'm going from mole to mole, I use my coefficients. So I have a 2 next to oxygen. I put a 2 next to oxygen. I have a 1 next to N2O4. I put a 1 next to N2O4. I cancel my units. Now I multiply across the top, divide by the bottom, and I get 0.326 moles of oxygen. So let's continue to look at our checklist. Mole to mole fraction, done. Mole to the goal, our goal was oxygen, done. So now we have our answer for number 1. Number 2, we have 1.25 moles of oxygen. How many liters of nitrogen at STP were needed? So we have a little twist now. We haven't done any with liters yet. So what we're going to do is we're still going to follow our same steps. I'm starting with 1.25 moles of oxygen. So that's going to go under oxygen. I want to get to nitrogen. I'm sorry, I don't have enough room. I'm just going to go this way. I want to get to moles nitrogen. And then ultimately, I want to get to liters of nitrogen. Now, when we first started doing moles, we learned there are 3 conversions: molar mass, molar volume, Avogadro's number. So molar mass is for grams, molar volume is for liters, Avogadro's number is for particles. So if I'm going from moles to liters, I need to use molar volume. So I'm going to use 22.4 here. So 22.4 liters equals 1 mole. So now I have my game plan. Now I'm ready to sort of work through my checklist and sort of set up my train tracks. So the first thing I look, is the reaction balanced? It sure is. Given to moles, well, the problem is given, my number starting is moles, so I don't need to do any conversions. And I'm now ready to set up my train tracks. So I have 1.25 moles of oxygen. I'm going to put that over 1. Then I'm going to bring moles of oxygen down, and I want to get to moles of nitrogen. Now the numbers that I put in front, I go to my balanced equation. There's a 1 next to nitrogen. There's a 2 next to oxygen. Now I've done my mole to mole fraction. Check. Cancel moles of oxygen. Now I'm ready to go mole to the goal. So I'm at moles now. So I have moles of nitrogen. I want to get to liters of nitrogen. So remember, if I'm going from mole to one other substance, I put 1 next to mole. Now the number I put next to liter is not molar mass now, it's now molar volume. So it's 22.4 liters. Moles of nitrogen are going to cancel, multiply across the top, multiply across the bottom. I get 14.0 liters of nitrogen. Problem number 3. We have, what is the mass of potassium nitrate when 2.04 grams potassium phosphate react? So now it's getting a little bit more complicated because mole isn't mentioned at all. I need 3 conversions. And it's saying potassium nitrate and potassium phosphate. So you need to know what those things are. So potassium nitrate is that, and potassium phosphate is that. So now we know that we need 3 conversions. We know what substances we need. We're ready to jump into our game plan, and we're ready to use our checklist. So first thing, let's look and see if the equation's balanced. And it is. Check. Now you notice there's no squares here for Bridge and Valley, so we're going to do it on our own. So I have 2.04 grams of potassium phosphate. So that's going to go in the valley below potassium phosphate. I want to get to grams of potassium nitrate. So I want to get to grams here. I cannot go side to side when I'm in the valley. So what do I need to do? I need to convert, and I need to get to moles of potassium phosphate. Then I can convert to get to moles of potassium nitrate. And then I can convert and get to grams of potassium nitrate. And those are my 3 conversions. 1, conversion ladder. 2, coefficient bridge. 3, conversion ladder. So now before we're ready to jump in, let's get our molar masses of K3PO4. So it's going to be 3 times potassium plus 1 times phosphorus plus 4 times oxygen. And I get 212.27. And then my molar mass of potassium nitrate is 101.11. Okay, now I'm ready to set everything up. I'm ready to do my train tracks. So I have 2.04 grams of K3PO4. I'm going to put it over 1. Grams of K3PO4 come down. Moles K3PO4 come to the top. We're going mole to another unit. 1 is next to mole. And now I put molar mass to 12.27. Let me neaten that up. To 12.27. Okay, now mole of K3PO4 comes down. Now I'm ready to cross the bridge. So moles of KNO3 come to the top. Now, because we're going from mole to mole, I look in my balanced equation, the numbers that are next to my substance, my coefficients, is what I bring down. So is a 3 next to KNO3, a 3 goes there, a 1 next to K3PO4, a 1 goes there. So now on my checklist, I did give into moles, and I've just done my mole to mole fraction. 1 more step. Mole KNO3 comes down. Now I want to get grams KNO3. Now it's mole to the goal, which is the mass of KNO3. So 1 goes next to mole. 101.11 goes next to grams. Now I go back, I cancel all my units. And I have everything set up, multiply across the top, multiply across the bottom, and I get 2.92 grams. Check my last box. I've done everything I need to do. Question 4. We have 5.8 grams of aluminum phosphate. How many moles of aluminum nitrate reacted? Well, first thing we do, mole is mentioned one time, so I'm going to need 2 conversions. Then I'm going to look, make sure the reaction's balanced, which it is. Aluminum phosphate is this right here. Aluminum nitrate is this right here. So I'm now ready to get my game plan set up my bridge and my valley, figure out where I'm starting, where I'm going. So I have 5.8 grams of aluminum phosphate. I'm going to put that in the valley. And then I want to get to moles of aluminum nitrate. Now remember, I can't go diagonal. I can only go up and down and side to side. So first thing I'm going to want to do is convert grams to moles. Then I can use my coefficients to go from moles to moles. So I have my game plan. First thing I'm going to do is I'm going to go grams to moles for aluminum phosphate, and I'm going to use molar mass to do that because it's a gram mole conversion. And the molar mass of aluminum phosphate is 121.95. Then I can use my coefficients to do my ratio, to get my ratio between aluminum phosphate and aluminum nitrate. Then I can do the math and I am all set. So let's start out with number, unit, and substance. Put it over 1. Grams of aluminum phosphate come down. I want to get to moles of aluminum phosphate. So that would be my given to moles. 1 goes next to mole. What goes next to gram is the molar mass of aluminum phosphate. So that's 121.95. Unit cancels. If I stop here, all I've done is converted to aluminum phosphate. But now I want to do mole to mole fraction. So moles of aluminum phosphate comes down. I want to get to moles of aluminum nitrate. I look in the reaction. There's a 1 next to aluminum phosphate. There's a 1 next to aluminum nitrate. Cancel my unit. Now, mole to the goal. Well, the goal was moles of aluminum nitrate. So I'm done. I'm done setting up my train track. So I'm going to multiply across the top, multiply across the bottom, divide top by bottom, and the answer I get is 0.0476 moles of aluminum nitrate. Question 5. We have 5.5 moles calcium carbide. How many moles of C2H2 are produced? This is easy because this is mole to mole. Mole is mentioned twice, 1 conversion. So first thing, balance the reaction. I look, the reaction's balanced. Next, I set up my game plan. 5.5 moles CaC2, so I'm going to put that right below CaC2. I want to get to C2H2 and I want to get to moles. So all I have to do, cross the bridge using my coefficients. So this one is just like what we did when we first started doing stoichiometry. Easy, easy, easy. So we have 5.5 moles CaC2, put it over 1, moles, CaC2 comes down, moles C2H2 goes to the top. I look up in my reaction, there's a 1 next to CaC2, there's a 1 next to C2H2, so the math is even easy. My answer, after I cancel the units, is 5.5 moles of C2H2. So I did my given to moles. It was already in moles. My mole to mole fraction, which is my coefficients. Mole to the goal. I am done. I have my answer. All right, question 6. how many moles of water are needed when 65 grams of CaC2 have reacted. Mole is mentioned once, so I'm going to need two conversions. So first thing, let's look to see if the reaction's balanced. It is. Now I set up my game plan. 65 grams CaC2, so that goes in the valley. And I want to get to moles of water. I can't go diagonal, so I have to first climb the conversion ladder using molar mass of CaC2. Once I'm at moles of CaC2, I can get to moles of water using my coefficients. So molar mass of CaC2 is 64.1. And I get that by multiplying carbon times 2 and adding that to the mass of calcium. So now I have my game plan. I'm going to go from grams to moles and then moles to moles using coefficients. So I'm ready to set up my train tracks. So I have 65 grams of CaC2, put it over 1. Grams of CaC2 come down, moles CaC2 come to the top. Remember, when mole to another unit, 1 goes next to mole. And then I'm going to put the molar mass of CaC2 next to grams, cancel my units. So now I've done step 2, given to moles. I've taken the given unit, I've converted it to moles. Last step, I want to go from moles to moles with the mole to mole fraction. So moles of CaC2 comes down, moles of H2O go to the top. So I look in my equation, a 2 is next to water, so I put a 2 next to water. A 1 is next to CaC2, I put a 1 next to CaC2. Cancel my units. I'm at the unit I want, so I'm done. I've done the mole to mole fraction. I've done my coefficients. And mole to the goal. Mole is the goal. So now I have my answer, and I get 2.03 moles of water. Question 7, in photosynthesis, water reacts with carbon dioxide to give oxygen and glucose, and it gives us the formula for glucose. A, write and balance the chemical equation. This is the first example where we actually have to balance the reaction and write the reaction. So with our checklist, the first thing we're going to do is get our reaction written and balance it, and then we can check that off. So we have water reacting with carbon dioxide, so you should know water is H2O. Reacting with carbon dioxide to give oxygen, and you know oxygen's part of Hankel-Briff, so I need my subscript 2, and then glucose, which is C6H12O6. And then I need to balance, and it is going to be balanced by putting a 6 in front of the water, a 6 in front of the CO2, and a 6 in front of the oxygen. Now, you should have used this reaction a lot last year in biology. This is talked about with photosynthesis and respiration, and you look at all these things in biology. So first thing, balance the reaction. We are done. Now it's saying how many liters of CO2 to make 120 grams of glucose. So mole is not mentioned. I'm going to need to do 2 conversions. One, I'm going to have to use molar mass because I'm dealing with grams. One, I'm going to have to use molar volume because I'm dealing with liters. So why don't we just try and set this one up using our checklist rather than using our bridge in our valley. So we have 120 grams of glucose. I'm just going to do GL for glucose. Put it over 1. So given to moles is the next step. Well, my given unit is grams. So gram comes down of glucose. I want to get to moles. Well, we know gram to mole, I need a molar mass. And I'm going to put a 1 next to mole because I'm going from mole to some other unit. Molar mass of C6H12O6 is 180.6 0.18. So that's the number that I'm going to put here. So check, given to moles. Now I want to go mole to mole fraction. Well, that means I need to use my coefficients. So moles of glucose comes down. I want to get to liters of CO2. So I first need to get to moles of CO2. And that is going to be a 1 because it's a 1 next to glucose. And it's going to be a 6 because it's a 6 next to CO2. Now, the last step is mole to the goal. So I bring mole CO2 down, and I want to get to liters of CO2. So 1 goes next to mole because I'm converting from mole to some other unit. And liters, the relationship is 22.4 liters equals 1 mole. That's molar volume. So now I do 22.4 liters. My units cancel. I have the math set up, multiply across the top, multiply across the bottom. I get 89.51 liters. All right, question 8. How many liters of oxygen at STP are produced when 20 moles of NaClO3 react? Okay, we have mole mentioned once, 2 conversions. So then what we're going to do is we're now going to work our way through the checklist. I want to balance the reaction. Okay, well, to balance the reaction, I need to put a 3, a 2, and a 2. So that's done. Now I'm ready to set up my game plan. I'm ready to set up my bridge and my valley. So we have 20 moles of NaClO3. So that goes on the bridge. And I want to get to liters of oxygen. So that goes in the valley. I can't go diagonal. So first thing I'm going to do is I'm going to convert to moles of oxygen using my coefficients. Then I can convert to liters using molar volume, or 22.4. Remember, when it says STP, that just stands for standard temperature and pressure. That just means you can use the 22.4 relationship. So we're now ready to set everything up. So given to moles, I'm given moles in the problem, so I'm already there. So I start with 20 moles of NaClO3, put it over 1, moles, NaClO3 comes down. I want to get to moles of O2. So I'm going to use the coefficients that are in my equation. So I have a 2 next to NaClO3, so that's going to come down here. I have a 3 next to O2, that's going to come down here. And so now I've done my mole to mole fraction. I've converted from one substance to another. Now I need to go mole to the goal. So moles of oxygen comes down. Liters of oxygen goes to the top. 1 goes next to mole. 22.4 liters goes next to oxygen. Now I have everything set up. Cancel my units, do the math, and I get 672 liters. Question 9. How many grams FeS are produced when 0.93 grams of S8 react? Okay, this is the most complicated because mole is not mentioned, so I'm going to need 3 conversions. First thing, balance the reaction. So we look, their space is there. Clearly the reaction's not balanced. So in order to balance it, I need to put an 8 and I need to put an 8. Done. Now I'm ready to set up my game plan. So I have 0.93 grams of S8, and that's going to go in the valley. And I want to get to grams of FeS. And I can't cross the valley, So I have to climb the ladder to get to moles. And I need a molar mass for that. And it's the molar mass of S8. Then I can use my coefficients to convert to FES. And then I can go down the ladder using a molar mass of FES. And those are my steps. So molar mass of FES is 87.92. Do that by adding together the iron and the sulfur. And the molar mass of S8 is 256.56 grams. All right, so I've balanced the reaction. Now we're ready to set up our train tracks. So I have 0.93 grams of S8. Put it over 1. Grams of S8 comes down. Moles of S8 goes to the top. 1 next to mole because I'm not going mole to mole. And now I put the 256.51 right here. That's the molar mass of S8. Now, given to moles is taken care of. Now I bring mole of S8 down. I want to get to moles of FES. So I look at the equation. I have an 8 next to FES, so that comes next to FES. I have a 1 next to S8, so the 1 is going to come next to S8. Mole to mole fraction is done. Check. Bring the unit down. Mole FES. I want to get to gram FES. 1 goes next to mole because I'm going from mole to some other unit. And then the 87.92 is the molar mass of FES. That goes there. I have now done mole to the goal. I have my math all set up. I get my answer, and I get 2.5 grams of FES. Question 10, we need to write a balanced chemical equation to represent combustion of decane, and then we're going to do our calculations with it. So it gives us the formula for decane. So we have C10H22, and then we're dealing with combustion, so we have to add oxygen to that. And the products of that are always CO2 and H2O. And then we need to balance. And then once we have that balanced, I'm going to need a 2. I'm going to need a 31. This one is a lot to balance. I'm going to need a 20, and I'm going to need a 22. So now once that's balanced, now I can then go to how many moles of water will form with the combustion of this mass of decane. So first thing, we have the balanced reaction. Then I look at the problem. Mole is mentioned once, so I'm going to need 2 conversions. And we'll do it without our bridge in a valley. We'll just use our checklist. So I'm starting with 540.4 grams of decane, and I'll just write D for decane. Put it over 1. Grams of decane comes to the bottom. Moles goes to the top. And so given to moles, I want to go from grams to moles of decane, and that molar mass is 142.32. And again, we get that by multiplying the mass of carbon times 10 and hydrogen times 22. So I take that molar mass, and I'm going to put that down here. And then I have 1 mole of decane. Moles of decane comes down. And now I want to get to moles of H2O. So what I'm going to do is I'm going to use my coefficients. So I have a 2 in front of decane. So that comes down here. And then I have a 22 in front of my H2O. And now I'm ready to do the math. And when I multiply and then divide, I get an answer of, and I'll write it down here, 41.77 moles of water. So if we look, we've done given to moles. This was our mole to mole fraction right here. And mole to the goal, we wanted moles, so we were done. So now we have our answer. Okay, so now, let me just move this up a little bit. We want to know how many moles of oxygen are needed to react with 8.65 moles of decane. Well, mole is mentioned twice, so it's just going to be one conversion. So again, I'll set it up with just my checklist. So I have 8.65 moles of the decane, put it over 1. Moles of decane comes to the bottom. I want to get 2 moles of oxygen. So the reaction's balanced. Given to moles, I'm already at moles, and now I'm doing mole to mole fraction. So in front of my oxygen is a 31, and in front of my decane is a 2. So that comes down. And so now I just multiply by the ratio of 31 over 2. I do the math, I cancel my units, and I get a value of 134 moles of oxygen. Question 11, we now want to know how many moles of NO are formed if 8 moles of NH3 react. And I have lines here indicating that it's very clear I need to balance the reaction. And so when I balance, I get a coefficient of 4. I get a coefficient of 5 for the oxygen, a 4 for the NO, and a 6 for the H2O. And now for this first question, mole is mentioned twice, so it's one conversion. So my given is already in moles. All I have to do is mole to mole fraction because mole is the goal. So I'm going to set it up down at the bottom just because there's not a lot of space. So I have 8 moles of NH3. And I want to get from moles NH3 to moles of NO. So I'm going to use my coefficients. So the number in front of NH3 is a 4. So that 4 comes down. The number in front of NO is a 4. So it makes our math really kind of easy. And it's 8 times 4 over 4. The 4's cancel. And I end up with 8 moles of NO. So my checklist, I have everything done. Answer for the first one. Beautiful. Now for B, it says how many molecules of water are formed if 29.95 grams of ammonia react. So we're going molecule, we want to get to molecules from grams. So mole is not mentioned. I'm going to need 3 conversions. So we'll just use our checklist and we'll kind of start from the beginning again. So balance the reaction, we already did that. Given to moles, so we're given 29.55 grams of ammonia. So I start with 29.55 grams of NH3, put it over 1. Grams NH3 comes down, mole goes to the top, 1 goes next to mole. And because I'm going grams to moles, that's a molar mass. And I'm going to need the molar mass of NH3, which is 17.04. Now I want to go from moles of NH3, and I want to get 2 moles of water. So we did given to moles, and now we're doing mole to mole fraction. So moles of NH3, I use my coefficient, that comes down. And then I want to get to moles of water. I'm going to use my coefficient here. 6 goes to the top. So now I can cancel these units. I've done my mole to mole fraction. And then my last relationship, mole to the goal, mole of water comes down. And I want to get to molecules of water. So now we're not using a molar mass because we're not using grams. We're not using molar volume because we're not in volume. So what's left is Avogadro's number. So we still can't get away from that. And remember that's 6.02 times 10 to the 23rd molecules in 1 mole. So you are now going to need to remember how to hit that into your calculator. I've done all my steps. Multiply across the top, multiply across the bottom, and I get 1.566 times 10 to the 24 molecules. Question 12, we are writing out a reaction from mercury to oxide decomposing into mercury and oxygen gas. So remember this 2 that we have represents our charge. So Hg is 2. Oxygen, because it's group 16, is 2 minus. So it's going to be HgO, and it's a decomposition because it says decomposes into mercury and oxygen. Remember, oxygen's part of Hankelbrief, so I need the subscript 2. And then I need to balance the reaction by putting a 2 in front of HgO and a 2 in front of Hg. Check, reaction is balanced. So now we go to the question, how many moles of mercury mercury oxide are needed to produce 12.5 liters? Mole is mentioned once. We're going to need 2 conversions. So we balance the reaction. First thing I'm going to do is do 12.5 liters of oxygen. Put it over 1. Liters of oxygen comes down. Mole of oxygen goes to the top. That's our given to moles. So 1 mole. Now I need to remember that liter to mole, I use 22.4. Now my liters are going to cancel. Now I need to go mole to mole fractions. So I need to get from moles of oxygen to moles of the mercury to oxide, which is our reactant. So moles of HgO. And so then I'm going to fill in my coefficients. So I have 2 next to HgO, and I have a 1 understood next to the oxygen. Units cancel. Mole to the goal. Well, I'm at moles, so I'm done. So I'm going to do 12.5 times 2 divided by 22.4, and I get 1.17 moles of HgO. Now, question B, we're using the same reaction, and we are asking how many grams of mercury are produced if a certain number of moles of mercury oxide are decomposed. So again, mole is mentioned once, 2 conversions. So balance the reaction, we're good. Now I need to get the given to moles. Well, the given is already in moles. So I have 24.5 moles of HgO. Put it over 1. Mole of HgO comes down. And I want to get to mercury. So moles of mercury is going to go to the top. And so I use my coefficients. So I have a 2 in front of HgO. So that goes in front of HgO. And I have a 2 in front of Hg. So that goes in front of Hg. So now I have done the given to moles. Check. And I've done mole to mole fraction. And now I just need to do mole to the goal. So moles of Hg comes down. I want to get to grams of Hg. That's a molar mass. 1 goes next to mole. And mercury, if you look on your periodic table, is 200.59. I can cancel my units, multiply across the top, multiply across the bottom, and I get a big number. I get 4,914 grams of mercury. Mole to the goal. We are done. Last problem. So it's asking how many moles of copper are needed to react with 3.5 grams of silver nitrate. So first thing, balance the reaction. So I look at this and I balance it, and I need a 2 in front of the silver nitrate and a 2 in front of the silver. And so for this last problem, because there's room, we're going to get back to the bridge and the valley. So I have 3.5 grams of silver nitrate, and I want to get to moles of copper. So first thing I'm going to do is I need to convert to moles of silver nitrate using molar mass. And that molar mass is 169.88. Then I can get from moles to moles using my coefficients. And then I'm done. So I've balanced the reaction. Let's now set up our train tracks. So we have 3.5 grams of AgNO3. Put it over 1. Grams AgNO3 comes to the bottom. Moles AgNO3 goes to the top. 1 goes next to mole, and then I'm going to do 169.88 grams given to moles. Check, and I've done this step here. Now, moles AgNO3 comes down. Moles of copper comes to the top. I have a 2 next to the silver nitrate, so that's going to come over here. And I have a 1 understood next to the copper, so I put a 1 there. Mole to mole fraction, check. I've now done that step. Mole to the goal. Well, it's asking for moles, so I'm done. So all I need to do is cancel my units, do the math, and I get 0.0103 moles of copper.